This presentation is part of a lecture series on the C++ programming language by Michael Adams at the University of Victoria in Victoria, Canada. And for those of you who might be interested, a copy of the slides for this lecture series can be downloaded from the website whose URL is given at the bottom of this slide. These lecture slides include many code examples, and I just want to take a quick moment to point out that in order to make a lot of the code examples fit on a single slide, it's necessary to make a lot of compromises in terms of good coding style. So keep this in mind when you're looking at the coding examples, and don't follow some of the bad practices that are used on the slides in order to make the examples fit on a single slide. So to begin with, we'll start with the basics of the C++ programming language. To begin, I'd like to make a few general comments about the C++ programming language. It was created by Bjarne Stroustrup of Bell Labs. Many great things came out of Bell Labs, including the C programming language, from which C++ is derived, as well as the Unix operating system. And originally, C++ was known as C with classes. It was in approximately 1983 when the name was changed from C with classes to C++, which was fairly early in the development of the C++ programming language. And the C++ programming language has been standardized by the ISO. Every ISO standard has a number associated with it. In the case of the C++ standard, it's 14882. And the most recent version of the standard is the 2014 version of the standard, which is informally known as C++ 14. And the next version of the standard is expected in the year 2017. The programming language itself is a procedural programming language, and loosely speaking, it's a superset of C. So in other words, C code will compile as C++ code for the most part. There are a few exceptions, but for the most part, it will compile and run as you would expect. The C++ programming language directly supports a number of different programming paradigms. It supports, for example, object-oriented programming as well as generic programming. And one of the driving forces behind the development of the C++ programming language was efficiency. So it tries to maintain all of the efficiency of the C language, but also it also adds many new features as well. And C++ is used in many different application domains, which is why it's a very good idea to learn C++ because there's a lot of areas in which it's used. And I've listed a few on this slide, such as system software, application software, and so on. The main thing, however, is because of the efficiency of the language, in any application where performance is really important, C++ is probably a candidate language to be used in that application. And lastly, there's been a number of other programming languages that have been greatly influenced in their development by C++, including C# and Java. So let's start out by talking about one of the most basic things in the syntax of the language, which is how you denote comments in the source code. In C++, there's two ways to denote comments, or two different styles of comments. One of them starts out with a double slash and proceeds until the end of the line, the current line. And the other uses a slash followed by a star and proceeds until the corresponding star followed by a slash. So I have some examples here of a few different comments here. This first line is using the double slash style of comment. So the double slash starts the comment and it proceeds until the end of the current line here. And then the other style, it starts with a slash followed by a star and proceeds until the star followed by a slash. And these style of comments, the ones that start with a slash followed by a star and proceed to a star followed by a slash, don't nest. So for example, in this example here, as soon as this star slash is hit, we're no longer in a comment, and this English language here, which is probably intended to be part of the comment, actually isn't, and this will generate a compile error. The next very basic thing to talk about are identifiers, and identifiers are just the things that are used to name various different entities in your program, which include things like types, objects, in other words, variable names, functions, and so on. So in C++, identifiers consist of any sequence of letters, digits, and underscores, but they can't start with a digit. So some examples of valid identifiers are listed on the slide here. Event underscore counter, event counter with a capital C here, sqrt underscore 2, and so on. These are all examples of valid identifiers. Identifier names are case sensitive. So for example, counter all in lowercase and counter with this mixed upper and lowercase are distinct identifiers. They name different things. So keep the case sensitivity in mind when you're writing code. Identifiers also can't be any of the reserved keywords in the language. There's certain words in the language that have special meaning, and you can't use these for identifier names. And the next slide lists all of these reserved keywords. And lastly, the scope of an identifier is the context in which the identifier is valid. So there's various different scopes that are possible. For example, global scope means that the identifier is valid essentially everywhere in the program. An example of an identifier that would have global scope would be global scope would be a global variable in your program, the name of a global variable. This slide lists all of the reserved keywords in the language as of the C++ 14 version of the standard. Note there's a few keywords that are context sensitive, the ones that are marked by stars here, which means that they only have a special meaning in certain contexts in your program. So sometimes you may be able to use these as identifier names, but probably it's better to avoid them.